Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. Today's lesson is confidence intervals for slope. Okay? Do students who sit in the front row do better than students who sit further away? Mrs. Gales took a random sample of 30 students from her classes and found these results. We have rows 1, 2, 3, 4, 4, and 5. And then we also have our scores for each of those children or for each of those students. And then we are going to continue with making our line of best fit. If you don't remember anymore, line of best fit is just the regression line. The y equals, or the predicted y. Let me write that down if you forgot already. So it is predicted y equals a plus b times x. I'm going to give you, because usually in the AP exam anyways, it'll give you a computer output where you are given A, B values, but you just need to identify where they are located in the computer output, which I will show you in the check understanding portion. So, granted that we already put all of these numbers in the calculator and we got our formula, and I will also show that in class if you forgot it already. So it's predicted score equals my A value is 895 plus the BO, actually the B is negative 1.517, and then times the row. Our slope is the B. By the way, this is y-intercept, and then this is your slope. So your slope here is negative 1.517. And our SE of the standard error of the slope is 1.33. Again, it will be given in the computer output. So if Mrs. Gales were to take another random assignment of 30 students, do you think the slope of the least squares regression line would be the same? Of course, it will be a no, right? In every random assignment will give different results, right? So it will give different results. Every random assignment will give different results with a new slope and with a new least squares regression line. So that's a no. Number 2, and I already said why. We are going to construct a 95% confidence interval for the slope of the population regression line. We are going to identify the parameter and the statistic. So by just taking a look at here, we want to get a confidence interval for the slope of the population regression line. Okay, so my parameter would be that the slope, right? We want to get the true slope of, right here, of the slope of the population or of population least squares regression line. And our statistic is the given slope of our sample. And then this is the only annoying part because you have to check 5 different conditions. 5, okay? Instead of 3 conditions, we're checking 5 conditions here. And I got this one. Remember the Staplet.com? Let me put that in here. Staplet.com. Remember we did this one on the first quarter? So on the Staplet.com, you can enter all of these data here on a toQuanti variable, and then you'll get what we call the scatter plot. Should I name this one? This is the scatter plot. This is the residual plot. It says in the thing, residual plot. And this one is the dot plot of the residual. Dot plot of the residuals. So here's how we checked our conditions. It's unlikely though that you will be asked to check the conditions in the AP exam for the slope, but just in case. So we call this liner. L-I-N-E-R. L stands for linear. Does the scatter plot here show a linear relationship? Or like technically what it means is, do you have something, is there a curve pattern going on in there? But it looks like it doesn't have, so the scatter plot is linear. And then the residual plot need to make sure that there is no leftover curve pattern. You remember the negative, positive, negative pattern? Okay, so it doesn't have like that, or a positive, negative pattern, something like that. So if it's not, then we're good to go. For independent, also for here, let's write the condition. For independent here, we have to check the 10% condition. So this is 30 is less than less than or equal to 1/10 of all students of Mrs. Gales. And then normal, the dot plot of the residual cannot show strong skew or outliers. So these does not look like you have, it's not skewed, obviously, and there's no outliers in there, so we're good. Number 4, equal SD. The residual plot does not show a clear sideways Christmas pattern. What that means really is that the dots are equal distance from this 0 over here, from the line equals 0, right? So each dot is approximately, that we'll say approximately similar from their distance to this one. Like, what does it mean by Christmas pattern? It would look like a sideways Christmas pattern like this, where the distance clearly show that it is from smaller, it increases like this, right? So if it shows like that, then that means that they are not equal standard deviation, or like X values are not equal distance from the line 0. Random, they did a random assignment. It did say it, right? A random assignment. Let's take a look. Random assignment of 30 students. Of 30 students. All right. Moving on. We are going to construct our interval. The general formula never changes. It's point estimate. And our point estimate here is the slope, plus and minus our margin of error. So that is specific formula. That is B. Let me just wipe a little bit, because my pen doesn't write correctly. There you go. So that's a B plus and minus T star and times the standard error of B, standard error of the slope. The bad thing about this one is it's not given on the worksheet tables. You guys have to remember this. And also, this is the same as the sample means anyway, right? So like you just mu, instead of B, it's mu, mean. And then it's also T star, and then standard deviation. Although the standard deviation is different. For here though, you don't have to solve the standard deviation because it will be given. If the data values are given, it's easy to do in the calculator. But if the data values are not given, you cannot do it in the calculator. You have to do it by hand. That's the only disadvantage on this one. So let's do the work. We are going to, and by the way, you know how to get the T star. Do you guys remember we need a DF, yeah? Our DF here is n minus 2. N being the number of sample, 2 because you know how we have X and a Y variable, a row and score. So we do n minus 2 instead of an n minus 1. I know, it's kind of like a lot to remember. So let's do the work. Our B, which is our sample, a negative 1.517 plus and minus. My DF would be, let's do a DF, n minus 2, 30 minus 2, DF of 28. So I'm going to go to my tables B, and I'm going to get DF of 28 and a 95% confidence level, because of course we're not, oh yeah, we are given 95 all the way up here. So hopefully when you look at your table B, your T star would be a 2.048. Okay? So that's negative 1.517 plus and minus 2.048 and times 1.33. I got the 1.33, this one, from my standard error of the slope, which was given right here when I started the problem, right here. Okay? So moving on, okay, back and forth. Let's solve these. What does this give us? So this is negative 4.24, comma, I'll just do a shortcut, 1.21. Okay, so that's it, you guys. And to make a conclusion, same thing. We are 95% confident that the interval from negative 4.24 to 1.21, what's that, points per row, right? Points per row captures the true slope, not the true proportion, not the true mean, true slope of the population LSRL for row, which is the X value, and score, which is the Y value. There you go. Okay. Do you remember that when 0 is contained and when 0 is not contained in our interval? In this case, since 0 is contained, right, 0 is in the middle of a negative 4.24 and 1.21. Since 0 is contained in the interval, it's plausible that there is no relationship between the row and the scores that students get. Okay, moving on. Important idea section. It's not really, I think the only difference here, I think it's a lot different, because of course, instead of saying true mean or true proportion, we are going to say true slope of the population LSRL for X, and then insert the context, and Y, insert the context. And that's it. And we have to do our confidence level. And then for planning, our name of the procedure, it's one sample T interval for slope, not for mean, not for proportion, for slope. And then for condition, it's LINER. And I guess you can see the previous page to see what it means by LINER. Oh, wait, again, let me just put that in there so that you don't have to. So linear, independent, normal, equal is SD, equal standard deviation, and then random. Okay? And then our formula is B plus and minus T star and SB. And what else? I think that DF. DF is n minus 2. Okay, let's apply what we learned. So you see how, let me name every single thing that is given to us in here. This is our A value all the time. This is our B value all the time. And then this is our standard error of the slope. Okay, and that's all we need. We can start. Let's start with stating the problem. State the problem. Our true slope of the population LSRL for weight, that's my X, and I didn't even read the problem. Number of balloons, y. Oh, let's read the problem. Sorry. A thrill seeker, okay, wanted to try to travel across a large field while being suspended in the air by holding onto balloons. Sounds dangerous. In order to determine the number of balloons needed per pound of weight, he did a preliminary study. He selects a random sample of 20 rocks of various sizes because he wanted to see how many balloons needed to successfully, or I'm guessing, to be able to travel across without any damage, I guess. So he weighed each one and also determined how many balloons are needed to lift the rock. Here is the output from a least squares regression analysis of the data. So we have output. I already told you which one is your A value, B value, and your standard error of the slope value. Okay, construct and interpret. Take note, 90% confidence interval for the slope of the population regression line. So I'm going to do 90% confidence level. And then I'm going to do my planning, which is one sample t interval for slope. So here's the thing. We have to check all of these conditions. Linear. Do we have a linear distribution? It looks like we do. So the scatter plot, I think let's do it in red because it's something new. The scatter plot shows a fairly linear pattern, and the residual plot is the next one, this one. The residual plot, residual plot has no leftover pattern. It's not a curve. There's no curve pattern in it. Moving on, independent. This probably is the easiest one. Independent. They did a random sample of rocks, so we need to do a 10% condition. Is 1/10 of all rocks. Liner N. For normal, we will do the dot plot of the residuals. The dot plot of the residuals. It's the third picture. This one. That's where we get the normal one. Dot plot of the residuals shows no strong skew or outliers. Okay, lin E equal SD. So equal SD means, let me make it bigger. Do you see how the distance of these dots, like for x value, right? For each x value, these are our x value for each weight. The distance of each of them, right, compared to this line is somewhat similar. So when I look at 0.5, right, around from 0 to 0.5, it looks like the distance of these ones are around similar. And then I know not all of them, some of them are like way far from it, but then it looks like for each x value, you see this, right? They're close to each other. It's not like the Christmas pattern like this, where it starts from smaller distance and then it gets bigger distances. Okay, hopefully that makes sense. But then it would always pass anyway. So you would always say residual plot. Okay. What happened there? Residual plot shows, take a look at what I'm going to say. Similar variability for each x. Okay? And then for random, we always just say that. Residual plot shows similar variability for each x. or each x has about same variability. You can also say that. We did a random sample though, yeah? Random sample of 20 rocks. Earlier, I did a random assignment because there was a random assignment. In here, I do a random sample of 20 rocks, but there was no random assignment in here. So for my do section, I will do B plus and minus T star and SEB. I'm going to figure out my DF first. DF is 30 minus 2, so my DF is 28. And my confidence level is 90%, so I'm going to look for 90. And then I'm going to look for 28. Hopefully, you will get 1.734. So let's do our formula. Our B value is 30.4126. 4126 plus and minus 734. And my SB is 2.0416. I got that. I got everything from the given output. So this is 26.87, 33.95. Okay? So for our conclusion, we always use the same conclusion. The only difference is, conclude. Okay. We are 90, not 95, confident that the interval from 26.87 to 33.95 captures the true slope of the LSRL for number of balloons. That's number of balloons is our Y. I didn't have space. And the weight, which is our X. And there you go. That's all you have to do. Okay, I know it's kind of a lot, but hopefully on the AP exam, if it does come up, they usually don't ask you to check these conditions though. Yeah, they will, usually they say, assume the conditions were met, assume the conditions are met, right? They usually do that. But just in case, make sure you know what each of them represents. Okay? That's it for today. And thank you guys. Again, this lesson is confidence intervals for slope. Thank you everyone. And I'll see you guys on the next video. Or I'll see you guys in class.